Cool. Hi, everyone. A little bit of echo, need to get used to it, but that's fine. Really excited to be here in Porto, actually my first time in Portugal. Really enjoyed it so far. Today we will talk about ARMGDN in a sense of how we will build modern web apps with Apollo, React, MobX GraphQL, various of databases, and Node.js. A little bit about myself. My name is Vladimir Novick. This is my fancy logo, which is basically copy-paste from VS Code into Sketch. That's how it turned to be. I'm developer advocate at Hasura.io. I'm also Google developer expert, author, consultant. And on a daily basis, I work in web, mobile, VR, AR, and IoT fields. I probably should add AI and blockchain to be on top of buzzwords, but still not there. You have my Twitter handle on the down left corner and my website, so if you want to reach out and say hi, feel free to do that. And today we're going to talk about lots of technologies. So what all these technologies are basically about and what we're going to talk about today. So we're going to talk about Apollo, about some reactions, about some weird things called MobX, types of graphs, elephants, and Node. Doesn't make any sense, right? So let's start with React. So how many of you have used or use React in production? Great. So you learned about React, or at least you use React, or at least you've heard about React. So React is basically everywhere. And if you've seen TV show Westworld, there's actually a fragment from the show when they use React create class. It's like an old version, but yeah. So assuming Westworld is not Facebook. We'll talk about MobX also. So MobX is, how many of you using MobX or have heard about MobX? Few people. So MobX is Redux. How many people have heard about Redux? OK, more people have heard about Redux. So MobX is another version of state management, basically state management solution that applies functional reactive programming principles. And today we will talk about MobX and MobX State Tree, which is a different state management, but based on MobX. So MobX basically gives you the following flow. We have, similar to Redux, we have actions, we have state, we have some kind of computed values that automatically trigger reactions. These reactions basically trigger a rendering and update of your state. It looks like this. We have a class to-do list, and inside of class we have observable to-dos and computed value. Whenever we will update these to-dos array, basically our component will re-render, and we will get our state, UI updated. So in a sense, it works like magic. But under the hood, it uses JavaScript proxies for doing all this manipulation that seems to be basically mutable. You can push into this array, but in fact, you create a new version of this array and use it on the client. So on the UI level, it will look like this. It will look like this. We have observer, which decorates to-do list view. And basically, we map over our to-dos and get a to-do view item. So whenever we change these to-dos, our component is re-rendered. Another concept in MobX, we can use action. So anything that we wrap with, decorate with action bound is basically considered as action. And in a sense, MobX is different from Redux. Redux is more strict. You have to use reducers, you have to call your actions, and everything works, and you know how to debug the whole process. With MobX, it's more like you can do anything that you want, works like magic, right? So that's why I prefer, for example, to use MobX State Tree. So it's kind of a love child of both of them, of Redux and MobX. And basically, it gives you a more structured way to work with your state management. So it's a quote from official docs. I won't read it. But it looks like this. We create our model. We have model, action, and views. Whenever we trigger action, we can update our model. And views are the ones that we consume in UI. So whenever our model is updated, the reaction is triggered, and the whole component is rendered. So it's more structured. I cannot update my models without triggering these actions. And it's more strict. It has its specific type system. For example, here I define that my model to do has a title and done, and the title is of type string. So it's more structured way to do that. And MobX state tree is actually considered one of the best practices for using with React. Not that Redux is not considered as best practice. So both of them, MobX state tree and Redux, are the solution for state management, right? So G in ARMGDN is basically GraphQL. How many of you have heard or using GraphQL right now? OK, few people, so I will explain a little bit further about GraphQL. So what is GraphQL? And before going into GraphQL, let's talk about REST. How many of you heard about REST APIs? Come on, everyone. So REST API, the core idea is good, is to have URL for every resource. In theory, it's fine, it works, but not in the real world scenario. We have like lots of coupling to implementation. We have lots of problems like overfetching, like underfetching. For example, if we want to get some resource, let's say we want to get a list of posts. And for every post, we have a user ID. And we want to get the avatar image of the user. We want to get its name. So we are talking about another request right now, right? So we have already 2 requests. And let's say a user has additional data. So we're basically coupling requests, or we're creating a specific endpoint that will serve the very specific purpose of the web app or the mobile app, right? And then we need to treat all this versioning, and it doesn't end. It just continues. So we end up chaining our request to server and to get the needed data. And the good example for it, I won't go into it right now, but you can check on your free time. Star Wars API is basically an API to getting data from Star Wars universe. And to get all films and directors and planets and vehicles, you need to do tons of requests to just consolidate everything on the client. And it's a tedious work, right? So what is GraphQL, right? And GraphQL is a query language of your API. And it basically works like magic, right? So that's how it looks like. It looks pretty much similar to JSON, but it's not. Notice we don't have colons here. We have some domain-specific language for querying the data. But you can notice here that I ask for all films and a title. And the shape of my data returned to the client is the same shape I've requested. So I can always know that the data that I requested will be the same when it's returned to the client. So this was the simple example. This is a more complex example. So here I'm using fragments, which are basically reusable parts of GraphQL queries, and a bunch of variables. And what I try to do here, I want to get all planets. For each planet, I want to get its rotation period. I want to get all the residents of the planet. I want to get what type of species this resident is, these residents are. I want to get all vehicles of the residents and in which films they appeared. So if we do it through REST calls, we have around like 8, I haven't counted, but it's around 8 calls for every planet, even more than that. So in GraphQL, basically, you define your types on your server. You define your schema, how basically your types are intertwined and connected. And then from the client, you can query your server and to get the data. Server works on the concepts of resolvers. It resolves this data from different data sources or from one data source and returns it back to the client in the exact same shape that you defined. So that's why it looks like magic. So how we basically, so let's say we have a GraphQL API. Fine, it's on the server, someone created a server for us, it's working. How we actually consume GraphQL API in React application. We are talking here about React application, but we can consume GraphQL API even from plain JavaScript. We can add script tag on our page, we can send a post request, provide its query, and we'll get the data. It's as simple as that. But with React, we have additional GraphQL client which help us with heavy lifting. So it's called Apollo client. And it has its own, sometimes has its own challenges, not like these ones. But it looks basically similar, not similar, something like this. We install packages Apollo client, cache and memory, React Apollo, and link HTTP. And what we do here, we define a link. A link, it's our endpoint that we will query. Here in this example, I will query endpoint. I will do queries and mutations. You can treat them as reading data and inserting, updating, or deleting data. There is another concept of subscription that we'll talk a little bit later. So I create this HTTP link, and I create a new instance of Apollo client, providing it with some kind of cache. So I have in-memory cache. And this is the additional cool stuff that Apollo clients brings us. It brings us its own caching system and caching solution. You can use in-memory cache. You can use Apollo cache persist. And basically, you can say, all my data that's received to the client can be persisted to local storage, and I have more performant requests and responses. So for using it in React application, we will wrap our app component with Apollo provider. This provider will we provide it with client and pass our new instance of a client inside. Whenever we do that, now we can use our GraphQL API for querying, mutating, or subscribing to the, in this case, for just querying and mutating. So what we do here, we have GraphQL tag package and React Apollo package. GraphQL tag package is basically your DSL for creating your queries or mutations. So it's basically tag template string, if you look at this correctly. So here we have the same syntax, the GraphQL syntax that I've showed you in the previously in Star Wars API and stuff like that. But here we have something pretty weird, right? So we have a query component, and inside we have a function as its children. So in React, this pattern is called a render prop. And basically, React Apollo supplies 3 components, query, mutation, subscription, with this render prop. So inside here, in this function, basically query component starts this fetch post request to the server, and returns either data, error, or loading. So here we can treat our loading states. We don't need to do this action if it's loading or to understand what's going on. We can just look at this loading, and if it's loading, we just return our loader. If we have an error, we will return an error. Well, in real-world scenario, we'll probably present some kind of toast message, something like that. And if we have the data, we can basically return our post list. So this is queries. Mutations are not so different. Mutations are basically a mutation component brought from React Apollo. And inside, you have the mutation function and the data. So whenever we execute mutations in GraphQL, we insert, update, or delete data, right? We get data back. So this is what this data stands for. This function stands for the actual, like calling the actual mutation. And you would expect to call mutation, for example, forms submit. So that's what is actually happening here. We have this add post. When we hit this add post, we pass a bunch of variables, and they go inside the mutation and create this, and basically execute mutation to the server. I'm going right now like pretty fast through the GraphQL. If you want to go like more in depth in GraphQL, so I recently released a free bootcamp. It's on YouTube. It's 4 days, 9.5 hours of studying, so you can completely check that. Or there are a bunch of additional info on both Apollo client and GraphQL in general. So additional thing that I already mentioned several times, so we have query mutation, we have subscription. So what subscription is? Subscription, remember HTTP link we've seen earlier when we set up our Apollo client, right? So this was link, HTTP link for basically our post requests with queries or mutations. Subscriptions work through WebSockets. And if you subscribe to changes, then the data that is updated on the server is pushed from the server to the client through the WebSocket. So we can get real-time GraphQL on our client. So here, for example, subscription looks pretty much, the syntax looks pretty much the same as query. The difference, though, is that here instead of query we have subscription, and over here we also have subscription. The rest, pretty much the same. The difference is in how it works. This one is working through WebSockets, and data is updated instantly. Whenever you query something, it's querying only when my component was mounted, and then it basically stopped querying unless you use some additional tricks, like, for example, in mutation, you can pass this probe, refetch queries. And then it will mean whenever you update the form, tell your GraphQL client to run this query again. So sometimes you will use subscriptions for real-time data, but sometimes you will just refetch your data again. So, OK, so GraphQL is a good thing, right? But what about MobX state tree? We've started with the state management, right? So Apollo client actually comes with its own solution for state management. You can treat the same as you treat your data on the server. You can treat the local data, local state in Apollo client. But in most real-world scenarios, you have already up with state management system that is working. You have a bunch of state, either in MobX state tree or in Redux. And basically, the concepts will be the same for Redux here. How I basically integrate between these two systems. So we will start by creating a service, or basically a function, that will get two properties, on error, on response. You want to call, you can call them whatever you like. And we'll have two methods inside. We'll return two methods, mutate or query. So if you look carefully here, what's happening, I am calling client.mutate. And yes, Apollo client not only exposes, and React Apollo not only exposes these fancy components with render prop, it also gives me the actual client that I can call the method on this client and call it to mutate my data or to query my data. So if I want to integrate my GraphQL client with existing state management system, I will create some kind of wrapper that I will use in my state management solution for basically querying the data. So in a MobX state tree example, we will have an action of update post and add post. So our add post will call our GraphQL service and provide two properties, basically, on error and on response. And each one of them will update model on the store. And I remind you, if you update something in MobX state tree, the computed values, the views that are defined in MobX state tree, rerun reactions, and then your component is re-rendered. So in a sense, you can just omit the query and mutation component and just use it inside any state management system. In this case, it's MobX state tree. So fine, we understood, hopefully, how we do this on the client. But what about D in ARMGDN and N, what we'll do with database, with Node, and basically what we will do about our GraphQL backend. And before diving into this, I want to talk a little bit about architecture and how we architect our web apps. So there is a software architecture proposal for creating modern web applications. And it consists of 3 factors. Real-time GraphQL. We already understood the benefits of GraphQL, hopefully, and like how clients can benefit from moving from REST API to something more real-time, something when we call our endpoint once and get the whole data that we need, and basically giving all the querying capabilities to the client, to the front end, instead of having lots of API endpoints and versioning them. So another thing that is in there in 3-factor app architecture is reliable eventing. And reliable eventing means that whenever we update something in our database, we want some kind of event to be triggered to do our business logic. Which brings me to the 3rd point, async serverless. So let's look at older architecture. We have an app, we have API layer, database, bunch of microservices. So our API layer writes into database, uses microservices for business logic and stuff like that. So it's synchronous in a way because we process something, then we write into database, then we return the response. Async serverless works, and in general, 3-factor app architecture works in the following way. We have some kind of real-time GraphQL API, and we have our state in database. And whenever our update to database is triggered, we want some kind of event system to trigger a bunch of serverless functions and write back into database. Now, because we are talking about real-time, and because we are talking about subscriptions, whenever our data is updated, changes will reflect back to the client instantly. So we don't need to pull anything. We will just return everything back to the client through the WebSockets, only parts of data that the client is subscribed to. So first factor is real-time GraphQL, and there are a bunch of solutions. One of them is Hasura, AppSync. You can write your own real-time GraphQL server with the GraphQL Yoga. You can write a poll server. These are a bunch of solutions that give you that in a different ways. On GraphQL Yoga and a poll server, you need to do things more, or write things more manually, write your own server, and Hasura and AppSync, it's sort of automatic. So second factor is reliable eventing. So there are 3 basically solutions. There are Division, event sourcing. You can implement your own event sourcing on your existing database or a new database, and basically whenever update or insert or delete is triggered on the database, you can call the event. Or you can use Hasura event triggers. And the 3rd factor is async serverless. And for serverless functions, you can use Lambda, Cloud Function, Azure, Zite, OpenFast, Kubeless, lots of solutions. So the question is, what is Hasura? Because AppSync you probably heard about. GraphQL Yoga may be something new. Hasura is basically open source. It's absolutely free engine. It gives you auto-generated real-time GraphQL API on top of new or existing Postgres database. So basically, you can take your database, you can take the whole let's say you have a business and you have a database with tons of data. You can just take the engine, run it on top of database. It will auto-generate GraphQL API, don't need to run a server, and then you can consume this API. So there are lots of features that it gives you. It can be deployed to any cloud and run locally because it runs in Docker container. So whenever you can run Docker container, you can run Hasura engine. It's compatible with all authentication solutions. I already mentioned that it can run on top of new existing Postgres. It supports not only Postgres, but also its add-on like Postgres and TimescaleDB. I already mentioned that it auto-generates API. And the thing is, GraphQL queries are compiled to basically performant SQL statements leveraging Postgres features. And we're not over with the features. There is a CLI tool that gives you migrations, like Rails-like migrations that you can run, and bunch of other tools. You can create your own SQL statements and make the engine to generate. Let's say you create a new SQL view or new function. Basically, the engine will automatically generate a query or mutation for you. You can configure your access control for data really granularly. You can say, I want this user with this role being able to update only this column in this specific table if like conditions are met. So you can go like really deep into granularity of permissions. You're not limited in any way. You can, for example, have your own GraphQL server. Let's say in .NET or in Go or whatever language you prefer, and you want to basically have the CRUD generated with the engine, but also have some custom business logic with your own GraphQL server. You can stitch the schemas. There is some concept so-called schema stitching, when you can take existing GraphQL server, like 2 GraphQL servers, and stitch the schemas. We will see it in a demo in a bit. It also has a venting system, which I already talked a while about that, about serverless function, how events are triggered. So the question is how basically to get started to just like get the hang of it. Obviously, like the setup that I will show you right now is just playing around with that. If you want to release things for production, you will obviously set up on proper cloud provider, either AWS, Azure, Google Cloud Functions, Google Cloud. But just for starting, you can go to hasura.io. You just click on Get Started. You click on this button, and you deploy things on Heroku. So when you click on that, you'll basically have 2 things installed. First, the engine. Second, Postgres add-on. That's what you will be presented after you run your app. You will have some kind of console that will have graphical IDE inside, and will have a bunch of additional tabs. It will have the graphical. It will have data. Data will be pretty much similar to pgadmin, and will get you access to your data on database. You can create tables. You can add relations between tables. You can do different things. You can actually run your own SQL statements. There is a tab with remote schemas that I already mentioned. You can stitch your GraphQL schema, and event triggers for creating custom serverless functions. So graphical tab will have a bunch of additions, like setting endpoint headers. You can execute queries, mutations, subscriptions. You can analyze queries. Basically, if you have a GraphQL query and you want to see how it's compiled to performance SQL statement, you can hit an Analyze button, and you will get the whole statement. So you can show it to your DBA and ask if this is performant enough. If it's not, you can always create a view with like more performant, and the engine will generate automatically for you queries on this view. So data tab is for managing data. It's for, I already mentioned all of these. It also has granular permissions control and access control. Remote schemas looks like this. So we can add our GraphQL server URL, and there we basically the engine will stitch automatically the schema. And event triggers, we can do a bunch of things. So to run Hasura locally, you basically just run Docker container, and you provide it with a database URL, which can be existing one, and you provide it with the environment variable GraphQL enable console, so you will be able to access this development console and do stuff with it. So the question is, I mentioned a lot Postgres, but what about supported databases? So is it only Postgres or it's not? So first of all, it is Postgres. It is Postgres extension like Postgres timescale DB. But actually, it's first time I'm sort of announcing it. We are bringing MySQL support, so it's coming soon, very soon. You can use NoSQL databases through migration by using JSON to GraphQL tool. So this tool basically gives you an ability to take the database dump, the JSON file, convert it to a bunch of migrations to put all the data inside your Postgres database, and then the engine will generate everything for you. And we even have Firebase to GraphQL tool that helps you with migration from Firebase, from existing Firebase app into Postgres, yeah. So the question is, where is Node in all of these, right? So Node is in the serverless part. And basically, it's not only Node. It was just for a fancy title, to be honest. But you can use any programming language your cloud provider supports for writing serverless functions. And this is, for example, one of the serverless functions that I will use right now for the demo. This function basically gives me filters all bad words from post that I will submit through mutation. So here, inside of my handler, I have a query, which basically a mutation. I update my post, and I update verified property on my post table. And inside the handler itself, I just run title and content through filter clean, which I brought from bad words package. So let's take a look at the demo and how it looks like. So, so I click on Get Started. I click on Deploy. So this is Heroku. Let's call it test NDC demo. Deploy an app. It will be pretty fast. So what it's doing is deploying the engine and starting the Postgres add-on for Heroku. And that's it. It's already deployed. So if I go to my console and I look at my queries here, I have nothing because I don't have any data in database. But let's actually create one. So we don't have any tables. I will add a table. I will call it posts. I will add an ID of type unique identifier. And I will create, this is a helper function for generating ID automatically. And I will have title of type text and content of type text. So my primary key will be ID, and I will also have a user ID of type unique identifier. So I created that. So this is the, so I don't have any data in database, but if I go to my graphical tab, go to my docs, I already have queries, mutations, and subscriptions. And basically all of these are automatically generated for me just from the data I just created. So what we're gonna do Now we will add another table. We'll call it users. We'll have ID of unique identifier, again with low auto generation, and our user will have first name of type text and last name of type text. So I select that my primary key is ID, and here you go, we have posts and users. Now, what I would expect, remember this like nested query that I did for Star Wars? Let's try to do the same here. So I will get my posts, and I want to get an ID. I want to get a title. Let me just enlarge it a little bit. And I want to get my user. So I would expect that because I have users and posts, I will get a user, first name a user, and last name, right? But if I'll try to do that, that's not the case. So why is that? Because I need to set relations. So I can go to my post and say that my user ID is a foreign key on users table. And the reference column will be ID. So now it suggests me to add a relationship. If I click on that, I can say that here is my user. Now, going back to graphical, I can actually, let me zoom a little bit, I can actually get my first name and last name. And obviously, if I run that, I won't have anything. But let's run a mutation. We'll add posts, and we will use insert post mutation. Emojis, why emojis? So we have insert post, and we'll pass objects. And our object will be title of hello, content of, and it will return an ID. So now if I run that, it won't work because I haven't set my user ID, and every post has to have a user. I can obviously go to modify my data to have these like non-nullable fields or nullable fields actually. But what I want to do here is something more interesting. I want to say that I will have a user with data, first name, and last name, and now it seems to work. If I go to my users, my user is created and my post is created. And this happened in two different tables, right? So it's a pretty neat feature, right? So we have these queries and mutations. But what about your custom server and about remote schemas? So I have here this Star Wars API server that I want to add, actually, yeah. So this is the Star Wars API and has a bunch of queries, does have mutations. So what I want to do, I want to go to my API Explorer here to remote schemas and add my custom server. Let's call it Star Wars. I will add a URL, add remote schema. Now, if I go to my graphical, I can basically query all films. So basically, it gives me an ability to access my other GraphQL server through schema stitching. So now I want to show you, because we don't have much time on like the whole thing, but I want to show you another example with a bunch of data already created here. So what I want to do here, and I have the same Star Wars API schema. So if I go to my posts, In addition to having, it's pretty much a similar structure. I have the author ID instead of user ID and timestamp, but I have another field called verified, right? And we want to run our serverless function whenever we insert our new blog post. And this is where our business logic will be. It will be in serverless function, right? So what I'm gonna do, I go to my Lambda console, and this is my AWS Lambda function here, with the bed worlds and like everything you've seen in the presentation, right? So I will take API endpoint for this Lambda function, go to my, if I will find it, where was it? I think here. Go to my Hasura console, to events, and I will add a new trigger. I will call it post verify, and it will be on table posts whenever I run insert, and this will be my serverless function. Let's add this event trigger. So right now, nothing happened. Let's insert a post. So I don't know, like if it will consider freaking as a bad world. But obviously, crappy will be a bad word, right? So let's add our post. Let's go into events. And we'll see our event was executed. And we'll see the payload of this event. Now, hopefully it will work. You never know with live demos. But let's go to our apparently crappy and freaking is not a bad word, so I have to be more, so forgive me for the, so let's call it shitty post. Let's run that. And let's check that. Cool. So it seems that it's working. So this is how my business logic works. It's async serverless. It works by executing these functions on serverless functions on updates, database updates, and that's how I can basically create my modern apps. So, how much time we have left? How much time we have left? Because I probably have time for questions right now. Cool. Let me just open it. Yeah. So this was the demo, and yeah, thanks a lot. This is my handle. This is my website. If you have questions, just raise your hand and like ask. I'm here. Come on, don't be shy. Yeah.
Does GraphQL support recursive queries? For example, a tree of a menu, where a menu or menu item can have children of menu item, and nesting level can be, let's say, unlimited, or maximum 5 levels.
Yeah, so I will repeat the question. The question is if GraphQL can support nesting to infinity, basically, like nested unlimited structures, right? That's the question. So in general, it's like bad practice to do because of the resolvers, how they resolve data. But here, like if you use, for example, with Hasura engine, everything is compiled to SQL queries. So it depends to like how performant your SQL query is. So in the end, it is compiled to SQL. And let me actually show you how it looks like. So for example, add nodes here, get posts. If I analyze my get post, I will get a SQL query. So basically, if you're infinitely nested structures are infinitely nested SQL queries, it's not a very performant thing, to be honest, so then probably it won't get like, the desired effect. The question is, why do you want to get into infinity? hope it answers. More questions? Yeah.
Just ask you all the related question. Is there any integration with .NET Core for REST APIs? Is there any?
So the thing, yeah.
This in a client to consume REST API?
Yeah. So the question is if there is any integration with the already existing REST API. This is really a good question, and this is basically the question that lots of people ask because, okay, in the real world, I already have something, right? I already have an application running with REST APIs. How do I start this migration process to GraphQL? So the idea there is, I will give you a GitHub example, for example. So GitHub used REST APIs, and they're still using REST APIs, but they have also GraphQL API. So how they transferred to be both GraphQL and REST. So what they did, they started to basically create GraphQL endpoints, and while keeping their REST APIs working. Whenever they finished their GraphQL API, they rewrote their REST API to use GraphQL under the hood. It get them to more performant, to be like more performant in a sense. And also, it moved there to the realm of like right now we have only GraphQL API working under the hood that we are supporting. REST is just a facade for GraphQL. So this is the one of the optimal migration paths. Another path that a company can follow is to start releasing new features while working on GraphQL, but still supporting REST. But at some point, it will get to the same, like the same solution as GitHub got to.
Does Hasura support changing naming convention from Haskell snake case for function names to, for example, more common for .NET or for JavaScript camel case?
You mean inside of, like, where exactly?
Insert underscore notice, update underscore.
Ah, OK. Yeah. So the question is if Hasura will eventually change naming convention to something more like more common in JavaScript or .NET world, right? So this is the question. Honestly, I don't know. But one really, really great thing about like being free and open source, it has Hasura has Discord channel, which really open to everyone, and everyone can join and suggest changes. And if these changes are suggested by lots of developers, these changes will be implemented. Like for example, MySQL support is coming because people ask for that. It was not an initial idea to bring MySQL support, but because people came to Discord and asked a lot about like how they migrate from MySQL, then Hasura decided to add MySQL support eventually. So I think if this question is, if like naming convention is a problem for like lots of people, then it will eventually change. More questions? Come on, bring it on. No questions? Cool. Then I will show you another thing regarding permissions that I actually forgot to show. There is a permissions field here in the console. So I can say that, for example, I have a role, let's call it test, and I want to say that for a test role, I want want it to be only read-only. So I say that my select for title and content field are working here. So let's save permissions. And then if I go to graphical, and let's say here will be test. So if you can notice here that I don't have mutations anymore. I have only queries and I have only subscriptions. And my queries for my posts or actually give me only content and title, because I set in permissions that this role is allowed to query only title and content. So this is for permissions. And yeah, and another thing like regarding authentication, so I told you about supporting different authentication solutions. So you can notice here we have Hasura admin secret. If you install Hasura initially, you will have this warning for securing your endpoint. And then the easiest way to secure your endpoint is just adding secret key. But you obviously know that it's not the production grade security, if at all. So basically, when the engine starts, it has authentication webhook that you can point to any authentication solution that you want. Whenever this webhook is returned back to the engine, then if we go inside the same permissions tab that we had here, you can add permissions based on the IDs or JWT token or whatever is returned from your authentication solution. So for example, I can say that I want custom check, I want my ID to be equal to a user ID, or be equal to some other header that is returned from my authentication webhook and passed to the engine. And speaking of headers, I can both pass all the headers that I want to the engine and use them here in permissions. Or if, for example, I have another server that I want to stitch schemas, I can add these headers here to like add additional like secured GraphQL servers and stuff like that. So yeah, cool. Any more questions? If not, more questions? No? Okay. Thanks a lot. Really enjoyed. Hopefully you also enjoyed.